Okay, I would like to dedicate tonight's lecture in memory of somebody. His name was Professor Schreiber, Aaron Schreiber. He was a great scholar. He passed away this year. And many of these topics I discussed with him. He was my inspiration to go to Columbia in the first place, and he wrote my first recommendation letter. And without anybody who applied to grad school, without recommendation letters, you can't get in. So, and we discussed many of these topics. He wrote a book. He was a professor of law at Brooklyn Law School, and he wrote a book about the quantum theories that we discussed together. So some of the ideas we'll discuss tonight are actually discussed by him in his book. If anybody wants afterwards the name of the book, I'll be happy to share with you. So tonight's lecture will be in memory of Dr. Schreiber. So just catching up, we've done the last two lectures. The first one was the scientific revolution, which went from Copernicus unto Newton. And then we digressed into Charles Darwin. Now, if you look at Newton, so Newton is the end of the scientific revolution because Newton found order to all the coming and goings of the universe. The order that he found in the universe was accessible by careful reasoning and mathematical analysis. The world was explicable and it was predictable. It was a world that was fun to live in. And that's the world that we got into seeing, and that's Newton. Afterwards, in 1850, what's the world? The origin of the species. And you have Charles Darwin, who has found a theory that actually can explain everything. So we have a Newton that explains the order of the universe, and Charles Darwin explains the origin of everything. It led to a very interesting comment. Albert Michelson, 1894, he was a renowned experimental physicist, and he says most of the grand underlying principles have been firmly established. The world felt in 1894 that everything had been resolved, that now we live in a world that everything is predictable. The biggest proof to it, if you remember, Huxley took evolution. Anybody who was here last week, just remind yourselves, and if you didn't see, please watch on the web. Huxley believed that the world is a progressionist world. The evolution is evolution of the species that continues today. That we have humans developing, and we went from the primitives to the Europeans to Victorian England in the 19th century. The world was still illogical, like Hegelian world. We're walking towards a very clear direction. Now I'll digress a little bit. You know, does anybody know who the Zohar is? We spoke so many times about the Zohar, and today the Zohar is going to become a very big topic of tonight. What is the Zohar? Huh? Right, excellent. It's the Book of Splendor. It was a Kabbalistic work that was revealed in the 13th, 14th century, but is attributed, was a tradition that was kept in secret from Rabbi Simon Bar Yochai from the 3rd century of the Common Era. And is one of the great Kabbalistic works, and probably is the revolutionizing Kabbalistic work that we have. So the Zohar says the following. The Zohar is an interpretation on the verses of the Bible. And the verse of the Bible, it says that in the year 600, in the life of Noah, God opened the windows of heaven, and the flood poured over earth. Everybody knows that's the beginning of the flood. Says the Zohar in his Kabbalistic interpretations that the year 600 of the 6th millennia, okay, the year 600, the floodgates of heaven will be open, and wisdom will pour down to earth, and his book, the Zohar, will be finally understood. So it's a self-prophecy. Okay, the Zohar was discovered in the 14th century, and it's saying about itself that in the year 600 of the 6th millennia. When is the year 600 in the 6th millennia in our Gregorian calendar? Which year is it? You know that the difference between the Hebrew calendar and the regular Gregorian calendar is 240 years. So it's the year 1840. 1840 was the year that God said that the floodgates of heaven will open and the book will be finally understood. Now, you know what the characteristic of the flood is? The flood, as it described in Noah, it's the rain, which is pouring from heaven, that destroyed everything, erased everything, and it created a new world. Right? If you read the story of the flood is the gates of heaven open up, the windows of heaven, and this great rain comes and erases, it effaces earth, and it starts humanity all over again. And the Zohar predicts that on that year will start a new era in the mid of the 19th century, that knowledge will be flooded and will be reconstructed. Okay? Self-prophecy of the book. And this is what happens. In the middle of the 19th century, the world is very comfortable that we've got everything. I told you, Michelson, the underlying theories have been found. However, Lord Kelvin, the famous Lord Kelvin, was a British physicist at around the same time, this is the end of the 19th century, says the following. He sees two clouds in the horizon. I always say it's very funny. The clouds of the flood are here. Two clouds in the horizon. This is a great picture. Two clouds in the horizon. He says everything has been answered, but for two little problems. We have a problem with the properties of light motion, okay? Because as you know, light, they had a problem of how light moves. So they believed that the universe is filled with something called the ether. In other words, because it's not the vacuum, because we knew the light in the vacuum moves differently. So the speed of light, we didn't have so clear. And the second thing is, well, some aspects in radiation. Besides that, we know everything. These two clouds created the effacing of the earth, and Newton became useless. These two created the greatest scientific revolution. That these two clouds created a science that destroyed the early civilization of Newton, that Newton was proved that everything he held was actually wrong. And this is what's called the postmodern science. Thomas Kuhn. Did anybody hear about the name Thomas Kuhn? It was mentioned several times, Thomas Kuhn. Thomas Kuhn is the philosopher of science. He wrote a book called The Structure of Scientific Revolutions. It's one of the best books on the story and the history of science, how the science develops. And he says like this: when you have a scientific idea, there are questions to the idea, and you try to answer. Ad hoc hypotheses. Answers are always easy to come up with. But sometimes the questions are such that they don't just require an answer, they require early thinking. They change the paradigm. And at a certain point in time, you realize, you know something, the questions are not just to be there to be answered. They are challenging the existing knowledge. And you come up with something completely different. These two clouds are the prototype, the paradigmatic challenge of existing knowledge and the creation of a new theory and world. Okay? Now, Principia Mathematica, that's the book of Newton. The Principia is based upon two ideas, and I'm going to read you. First of all, time is absolute and immutable. Time is a given. And the universe is a rigid, unmoving arena. And gravity just pulls things together. But it's a fixed theater of operations, and things move in it. Time and space are set. As you realize that the light motion challenged that. And there was a scientist, and I'm going to spend much time on it, that we spoke last week, who challenged in the rigidity and the immutable part of time, who was the one who challenged Newton and took him to task. His name was Albert Einstein. Albert Einstein realized that time is not immutable. Time is relative. Time is not fixed. And he created what we saw last week, which is the time dilation. Time doesn't move in a constant. Time is in relation to mass and to velocity, to speed. And this is the famous time dilation, that the clocks will run slower as one approaches the speed of light, and at the speed of light, time stops. And this became a complete challenge to not only Newton's theory, to Newton's existence. Now this is very interesting, because the Zohar, as we spoke last week, is filled with this idea that time is not an absolute. Time is relative. We saw last week the concept of the 4 universes. 4 universes, 4 degrees of consciousness, 4 worlds. And his whole theory that the book is saying is that these universes are correlated, but the flow of time differs between each one of them. That as you approach a more spiritual world, time will run slower. In other words, you will be able to accomplish more. So this is right away something very interesting. That first, I always think that when you read a book from the 14th century or attributed to the 2nd century, meaning those old traditions, and they're telling you that time is relative, and not only that, time and space are connected, probably never made any sense. But after the floodgates opened, actually, it does make a lot more sense. That's the first challenge. Today we're going to spend time in 2 things tonight. We're going to spend time about quantum and about string theory. String theory is the 1984, the most advanced physics theory, which is gaining a lot of momentum, and we'll see how this language, as much as evolution challenged religion, quantum, and as you'll see, the string theory not only doesn't challenge religion, probably cannot be understood outside of the realm of Kabbalistic thought. And that's, by the way, does anybody know Brian Greene? So Brian Greene, we had a very interesting discussion. He's a great guy. He's a professor at Columbia Physics. And it's clear, those ideas are very clear that these are mentioned in ancient books already a long time ago. But we'll go step by step. Quantum mechanics. What's the difference between the world of relativity and the world of quantum mechanics? Anybody would like to share some thoughts? Big and small. Excellent. Relativity is the cosmic world. Great bodies, great distance, that's how you deal with it. Quantum, Newton relates to the world which is visual. Anything that you leave here, an apple falling from the tree, this is great for Newton. The problem is Einstein saw that as you go to the great bodies, right, the stars, the planets, Newton breaks down the concept of the fabric of the time-space. That breaks down. Quantum is when you go to the very tiny microscopic places, that you go to the neutrons, and you go into the neutrinos, which are very teeny tiny portions of the atom. Newton breaks down for a different reason. And that was what we saw before, the aspects of radiation. The radiation that was being emitted by those different neutrons and neutrinos and the ions and so on and so forth, they violated Newton, and we'll soon see how. Who is the great architect, one of the primary architects of quantum physics? That he is part of what's called the Copenhagen interpretation of quantum physics. Quantum physics was something very complicated, and there was something called the Copenhagen interpretation. That's Niels Bohr. You see, always people try to compare. How do you relate Niels Bohr to Albert Einstein? Albert Einstein is the genius of the 20th century, early 20th century. Niels Bohr is probably as great as he was, but in the world of the micro. But you know what he said? Quantum is such a difficult thing that ordinary language can't explain. You know why? Because the world that we live in, it's not real. It's an ambiguous reality, as we're going to see. The probability, the concept of probability that nothing is a given, is woven in the fabric of quantum reality. Now, I'll tell you something very interesting. He said himself, do I really understand it? His famous quote, and I'm going to read, he says like this: This is Niels Bohr. He is the father of quantum mechanics. He says like this: if someone says that he can think about quantum without becoming dizzy, that shows only that he has not understood anything whatever about it. He was used to say a famous joke. It's a joke about rabbis, so I think it fits on for tonight. He said that he was used to tell when he would discuss about quantum, because quantum, as you'll see, is something that is almost impossible to understand it within a world which is visual. In other words, as much as things make sense when you see them, if you go to the subatomic level, you realize that they really don't exist. And you don't see, I will explain to you how. But he used to say the famous story about the three rabbis. He says there were three rabbis who gave a lecture. So his friend asks him, okay, you went to these rabbis, so how were the lectures? He said, listen, the first guy was a great lecturer, was very clear, succinct, was very well understood, and I really got it, and the rabbi really understood it. So he said, so how was the second? He said, the second was even better. I'll tell you the truth, the rabbi really understood it, but I really didn't get it. But that was much better than the first. So he says, and how is the third? He says, the third was the best. That was the deepest and best presentation of all the three. So he says, what's special about it? He said, because that's such a deep presentation that neither the presenter nor me understood it. The rabbi and myself had no clue what went on. He says, that's quantum. Quantum is a world that you realize that nothing makes sense. And this is the father of quantum, Niels Bohr, and this is the great achievement of the 20th century. By the way, as crazy as these theories are, all of the advancement from the iPod to television are based on his theories of quantum, and without those formulas, we would not have television, radio, anything like that. Okay, here we go. Light. We know that the light posed the greatest paradox in life, because Einstein won a Nobel Prize to explain that light is made out of little particles. Does anybody know the name of the particles, which are little teeny microscopic particles? Yes, the photons. He won the Nobel Prize, and they were particles. Now, what is interesting, what's the difference between particles and waves? You'll see here, this is waves, and this is particles. Particles here, these are waves. If you see something interesting, waves move constantly. And the particles, they rest. It's the little particles, right? And the waves, they meet and they interact. As you can see, they interact, right? And you'll see that particles never interact. They go straight. And light, Einstein had decided the light are particles. But as you know, the Huygens already at that time thought that light are not particles or waves. And this was until a guy called Thomas Young. And Thomas Young made an experiment, very easy experiment, using light beam against a wall. And the wall had one or two slits, openings. And there was a plate behind it. And he proved that the light are not particles, they are waves. And he created the famous question that we know light is either waves or particles. If something's a particle, it can't be a wave. And if it's a wave, it can't be a particle. I told you waves move, particles stand. Waves interact. They have the crests and the troughs. They offset each other. And by particles, they don't do that. So it's either or. So what is it? And this created the big dilemma until quantum physics explains it. And you know what the quantum physics says? And that's the famous idea of Niels Bohr. His greatest contribution to science is called complementarity. So you have waves and you have particles. And he says, no one told me that I was going to have to work with her. Complementarity tells you that light is both. It's waves and it's particles. How can it be if they are mutually exclusive? It all depends on how you approach it. Because if you measure it as a wave, it will react as a wave. But if you measure as a particle, it will react as a particle. So the reality is not fixed. It's dependent upon how you approach and how you measure it. And that's called the world of complementarity. which means that the world is not defined. It's a probability until somebody, a human consciousness, measures it. Once you measure it, you establish. Light becomes either wave or particle. But until you measure, they could be both. So you could have the wave telling the particle. I didn't know they were supposed to work together. I mean, it was supposed to be mutually exclusive. And this leads to the famous Schrödinger's cat. Schrödinger's cat is the famous theoretical explanation that if you have a cat that's dependent upon that if there is a particle, he'll die. If it's a wave, he'll live. This cat, it's going to be in limbo until somebody decides to measure light, if it's a particle or if it's a wave. Because that will make the cat dead or alive. So that's why you have the ESPCA that was arrested for the cruelty to animals, and his fate is uncertain because you don't know if it's cruel until somebody measures light to know if it's a particle or a wave, and this will determine the fate of the cat. This is a world which observes determination. Rule 101 of reality. In reality, if you go into the subatomic particles, they don't exist until somebody measures it. Heinz Pagels, like New York Academy of Science, no meaning to the objective existence of an electron. Electrons don't objectively exist. This takes Newton and throws it out. It doesn't exist. Now, the electron seems to spring into existence as a real object only when we observe it. So it's a funny universe that until we observe it, it doesn't exist. We just don't listen and watch reality. We actually make reality. Is the concept of complementarity. Now, it appears to be not even science fiction. It appears more like science madness. But this has allowed us to watch television. If you go tonight to watch television, it's assuming these concepts of the light, particle, wave duality. What does that mean? How you have a universe that's determined? And I told you, Schrödinger says, it's not only relevant to subatomic particles. I told you because you could create an experiment that the cat will be zapped if it's a wave and will be alive if it's a particle. But until we decide, the cat is in limbo. Because once you decide, it becomes a particle and the cat is dead, or vice versa. So in other words, if you are going to, the cruelty to the animals is uncertain. How does that make sense? And that's why I told you, Niels Bohr says that if anybody tells you that he understands quantum, he either doesn't understand himself, he doesn't understand what understanding is all about, or he has no idea what quantum is. Now, the funny aspect is that the Zohar and Jewish thought is permeated with this idea. This idea is an idea that has been with us for thousands of years, which is called the human determination of reality. When God created the world, it's very interesting. It says, when God created humans, God said to humans, let us make man. Right? What does it mean, let us make man? Who's the us? Huh? Elohim. But Elohim is God's name, so it's not an us. See, a Jewish thought always believed, even though the name is in the plural, it's still one deity. All Jewish faith is based upon the concept there is monotheistic or monistic. So who is the us? So the Kabbalah books, and the famous one is, the Sfat Emet says that, but it's brought down already in the name of the Zohar, that let us is the God told man, let us, me and you, make yourself. The humans determine. That's why the world is created. It says in the chapter of creation that God created the world to be made. Asher bara Elokim la'asot. God created the world to be made. What does it mean, the world to be made? So the Nachmanides, which is one of the great commentators based on Kabbalistic thoughts, he says the following idea. The world, when it was created, it was tohu and bohu. Tohu in the wilderness of the world is something called tohu and something called bohu. What is tohu and what is bohu? Tohu is the potential. Tohu is the question of bewilderment, that you don't know what it is. Is this uncertainty. Tohu is in Hebrew, melashon lithot. In Hebrew, when you have a bewilderment, you don't know where something is, it's called tohu. And bohu is defining it. Bohu means from the word in Hebrew, bahu. This is what it is. The world was created as a range of possibilities. That's what Nachmanides writes in the 14th century. The world was created as a range of possibilities, and then you define one of those possibilities. Who does the definition? So says Nachmanides, the world of definition was created that the humans. God created the world to be made. He created the world with a range of possibilities that the human defines it. So that definition is human. And that's why it says that God created the world to be made. It was tohu, as in creation, and the bohu, which is defining that probability, is the human partnership in creation. Our human participation is defining that range of possibilities. And that's why when God said, let us make man. Let us make man means let me and you make yourself. Look at the Bible. Who gives the names to the animals? Adam. Why does Adam give the names? Like God wasn't creative enough and he needed somebody to give names, like he couldn't come up with names? I know that names are always a big problem. I always get phone calls from people who have problems with what names to give. But it's not that hard. Today even you go to the web, you could find millions of names. So why did God require Adam to give names? But you know why? Because you know what names do? In Hebrew, in Jewish thought, names define something. They give a definition. The name, Aser Sam Shamot, the name Shem in Hebrew, comes from the same etymology as the word Sham there. It defines. Names define. Man was supposed to give names because the definition is human. It's exactly quantum theory. That until the observer observes it, and has to be a human conscious observer, until then, it's only a range of possibilities. The universe is a range of possibilities. Light is both particles and waves until a human decides what it is. And that defines the fate of the cat. So what to Niels Bohr was something that made no sense. Has been in our Jewish thought forever. It's based upon our predication. All the partnership, we always talk about tikkun, that the world, we believe, was created incomplete. And we as humans have the task to complete the act of creation. What is the completion of the act of creation? Is defining the range of possibilities. Okay? Interesting. Next, quantum. What's the second quantum? So now you know what's the rule number one. Niels Bohr's greatest contribution. Remember one word called complementarity. Complementarity is that both ranges, opposites, coexist. Niels Bohr. Second issue of quantum. Called non-locality. What's non-locality? What, according to Einstein's relativity, theory of relativity, what is the fastest speed any mass can achieve? How fast can you ever go? What's the speed limit of the universe? The speed of light. So, superluminary communications, you can't communicate faster than the speed of light because you can't send information fast enough. Now, quantum has proven that the world totally communicates superluminary. But even more, let me give you a famous example, the iodine 125. Let me just get you the details. The iodine 125 has a half-life of 65 years. Does anybody know what the half-life of 65 years is? That every 65 years, half of the amount will be gone. Half of the amount will be gone. So if you had, let's say, a gallon of iodine 125, in 65 years, you would have a half a gallon. What will happen in the next 65 years? You're going to have a quarter of a gallon. Now, the big conundrum is, how does one atom know that it's his turn to go? Right? Because half means that half of them will be gone, and half of them will stay. Now, who selects who goes and who stays? Is a half of every neutron can go. So there is a line of neutrons who are supposed to be killed, and a line of neutrons supposed to stay. But it's only half, because they're only half alive. Who makes that decision? So that is a question that has been asked forever, until they had something called the entangled photons. Photons can be split in such a way that there is a photon, and there's a mirror image of the photon. They get split. But you know what's amazing? Whatever it happens to one of them will happen to the other one. They are like Siamese twins, even though they are separated by millions of miles. And the question is, how can each one know what the other one is doing? Because they would have to send some kind of a communication form, and this is faster than the speed of light. So you can't have the communication above the speed of light. Brian Greene, he says like this: the sunglasses, if you have a photon, two entangled photons, and you have a photon that's sent to the pavement, and it reflects back to your glasses, and your glasses are coded in such a way that 50% of the ray lights go in, 50% don't go in. So whenever the photon is flown back, they say the sun shines on the pavement and reflects back to you. So your glasses will reflect back 50% and absorb 50%. It's proven in quantum theory that what one photon does, the entangled photon will do exactly the same thing, even though they are apart in a way that they can't communicate faster than the speed of light. So how can things communicate above the speed of light? And that's theory number 2 of quantum, non-locality. You know what means non-locality means? That there is no place. That the world of reality, it's entangled in such a way that all communicates together. Reality is one unique fabric that you don't have to communicate. The two photons, they appear to be separate, but there's no locality. They are really the same existence. It's called the unity of the fabric of existence. We know today, for a fact, that neutrons communicate with each other beyond the speed of communication, which means that all existence is one. There is some kind of a unity that allows all of consciousness of creation to behave as it was one. The iodine 125, the two atoms know, because they communicate to each other above the communication, because they're part of the same being. It's called the non-locality of existence. How is that possible? So the second very big important issue, two contributions of quantum: non-locality and complementarity. Now, non-locality, how is that possible? Why is reality in such a way connected that it communicates with each other beyond and faster than the communication? There is a unity of being. What is this unity of being? And you realize that Niels Bohr famous quantum, those two, complementarity and non-locality. But if you look in Kabbalistic thought, people, this is what Kabbalists have said always. Remember, how was the world created when we spoke about it last week? What's the symbol of creation that the book of creation represents as the beginning of creation? The scale, the two-sided scale. The universe was created, there is reciprocity in such a way that the world of correspondence, that reality is interconnected in such a way that one action creates an effect on the other one in a magical way, because it's unity. And unity comes from something called the tzimtzum. You know what the tzimtzum is? All of reality is divine. We know and we believe that God is the only reality. God hid himself into reality to allow reality to take place. But divine being is one. So the oneness of creation, which creates reciprocity, that if you move one side of the scale, the other side will move, is the fabric of creation. The unity of being is the ultimate belief of the Kabbalists. And by the way, it's not only Jewish mysticism. All the mysticism will believe that the world is one. Anybody who saw The Matrix, what's Neo? Right? Neo is the one. that all of reality is a great consciousness that allows this reality to take place. Exactly quantum theory. The world communicates with each other. We have a world that behaves as one being. As much as we see ourselves with different agendas, different political parties, we are constantly fighting with each other. We are the same thing. It's all one. And the principles of non-locality not only prove that, they depend upon it. Just to think about it. And you should know something. We spoke about evolution last week. Why was the world created? For us, that we believe the world was created by God. Why did he create in an evolutionary system? Why didn't he create the world already? Because the symptom, when God constricted himself into the world, the Kabbalists say that he constricted himself in phases to allow the human to transcend, to allow us to connect to God in like Jacob. If you remember Jacob, how did Jacob connect to God? There was a ladder that was standing its feet on the ground and was reaching heaven. And there were steps. That step-by-step communication with God, those are the levels of evolution, which is the constriction of God. The God constricts himself and he hides himself besides reality, but it's all one. Okay? So this is what quantum is all about. But I'll tell you something more fascinating, because we're going to go into string theory. Brian Greene says in his book, and he says very interesting and funny, we spend billions of dollars. Did anybody hear about the new super collider in Geneva? We just built the most amazing super collider in Geneva that's taking scientists from the entire world and costs more money than to solve a great problem of the world's deficit was spent in the super collider. So we spend more money than anything else. But you know, after we analyzed everything in the universe, how many forces are there in the universe? After every money was spent and etc., we found how many forces? There are 4 forces in the universe. Brian Greene says, very funny, they're not 5, they're not 6, they're only 4. Now what are they? The 4 forces of the universe. The universe that we live is based upon these 4 forces. It's gravity, the electromagnetic force, that's television, etc., the strong and the weak, which are nuclear forces in the subatomic level. These are the only 4 forces of the universe. So Brian Greene writes, and he says, very funny, why 4 only? Why not 5, not 6, 3? Who decided 4? And there are only 4. But let's go to the next video. Now let's talk about Sheldon Glashow and that Steven Weinberg and Abdul Salam in 1979 independently created and developed the electroweak theory. And their theory, which unifies 2 fundamental forces. That even though we have 4 forces, but at the root, at the beginning, there were only 3. Because the electromagnetic and the weak, there were 1 at the time of the Big Bang, and they separated. It shows how the weak nuclear interaction responsible for beta radioactivity decay and the transformation of hydrogen into helium, okay, is a different example of the same force behind electromagnetic fluctuations. Electromagnetic and the weak are the exact same thing. They just express themselves differently. I'll tell you something fascinating. The number 4 is a number that's repeated in Kabbalah all the time. Can anybody give me examples of the 4? Jewish examples of the 4. Let's talk Jewish numerology. Any examples? Quickly. 4. The 4 matriarchs. Very good. Then something else. The nights of Passover. How many glasses of wine we drink? We drink 4 glasses of wine. The 4 questions. But let me more. How many letters, the tetragrammaton, God's name, how many letters does it have? It has 4 letters. Excellent. Now, in the Garden of Eden, how many rivers were flown out? How many rivers flowed out of the Garden of Eden? 4. Says the Maharal. The Maharal is the great sage of Prague in the 17th century. We mentioned so many times that that's how we started the series. He says, if you look in Jewish law, that's what he wrote in the 17th century, and it's printed. I have the first copy. He says, you look at it. We said, right. In other words, it's not something made up. It's always used. You know, hindsight is always 20/20. I can't make up anything going back. But what he says is the following. You should know in Jewish thought that even though 4 is the operative number, it's really 3, and the 3 divides into 2. He says, explains the law, because in Jewish law, he comes to explain the following. There are 4 cups of wine that are drank in the night of Passover. But you are allowed to interrupt or to drink something in between the first and the second cup and the second and the third cup. You could drink, you could eat, you could do whatever you want. 2 cups of wine cannot be separated. They have to be drunk, and nothing can be drank in between the third and the fourth cup of wine. So he comes to explain, it's a crazy law. Why can't you drink wine between the third and the fourth cup? He says because the third and the fourth are always connected in Kabbalistic thought. Look at the God's name. How many letters is the Tetragrammaton? 4 letters. But how many individual letters they are? How many unique letters? It's 3, because the Hey is repeated twice. The 4 matriarchs. What's unique about the 4 matriarchs? There is the third and the fourth are sisters married to the same father. Look at the rivers of the Garden of Eden. They are Hidekel and Prat, 2 names, and then Gishon and Pichon. Pichon and Gishon. 2 names, Pishon and Gihon. I'm sorry, it's Pishon and Gihon. The names are monuments, and they sound the same. Pishon and Gihon. Says the Maharal because they are the same. The idea is that if you look at the concept of the third and the fourth, they are always connected. Because in creation there were 3 and they were separated, but they still become together, which is exactly how reality follows. You have the 4 forces of reality, and the electromagnetic and the weak force are the exact same thing, the representations of the same idea. Because all in the world of reciprocity follows together. Modern science, if you understand, it is not only compatible with Jewish thought, it is the best expression of Jewish thought. And I'll show you the next step of it. So in this world, that now we have the 4 forces of the universe. And we have 2 theories called relativity and quantum. We got into a world that created a great problem. You know why? What is the basic theory of quantum? The quantum is non-locality, that there is a unity and unification of reality. Reality is all one. But you know the problem is? Because relativity and quantum are not compatible. General relativity, as we spoke about the large astronomical distances. Quantum mechanics are the microscopic properties of space. The domains of applicability are separate. It was very easy to play with quantum and with relativity. Relativity, you played with the big bodies. Quantum, you played with very tiny bodies. But you know the problem is? If you try to reconcile the 2, you came with the most incoherent model. You know why? Because if you incorporate quantum and relativity in one model, you get a nonsensical answer. Because you get an infinite probability. You realize probability can be 1, but it can be an infinite probability. If you combine the mathematics of relativity and you combine with the mathematics of quantum, that you find something that needs both, it's insolvable. Because once you apply both, the probability of something happening is infinite. So the world has been constantly in search of a unified answer that will allow relativity and quantum to coexist. And also, if the world of unity, if there are 4 forces of the universe, now we know it's 3, how do we connect it all to create a general answer for everything? To create a unified theory of everything. And that's the world of stream. Okay. The unified reality. The world of unified reality, we are looking for unity of knowledge. If quantum tells us, non-locality, that the physical reality is all unified, knowledge has to be unified also. What is unification? Is consistence. Consistence means that if you have a theory, it has to make sense in early permutation. And then you have something called consilience. You know what consilience is? That if a theory is right in one aspect of reality, it has to make sense in every other single aspect of knowledge also. Consistency is a coherence within itself. Consilience is a consistency outside of itself. The world has been in search for it. You know the Hebrew word for the word truth? How do you say truth in Hebrew? Emet. You know what's amazing about Emet? It's the same Maharal, the great sage in Kabbalistic in the 17th century says. You know what's special about Emet? Aleph is the first letter of the alphabet, Taf is the last letter, and Mem is the middle letter. Because truth is consistent. It's coherent, it's consistent, and conciliant. The only time you know that you've achieved the truth, if you find something that fits, is one size fits all. And after the world of quantum and relativity shows that we have a world of relativity in the great bodies and the world of quantum, the small realities, how do you reconcile both? And until these two guys come, 1984, so I think most of us were born already by 1984. Who was not here by 1984? I don't know. So this is, I'm sorry, old theories for anybody who wasn't in this world in 1984. But for people like me, this is something very recent. 1984, Michael Green and John Schwartz, from MIT, they come up and they find something. You say, you know something? Till now, since the Greeks, the world is made, if you go to very, 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 very small existence, it's made of little points. The neutrons, the eons, they're very little points. They're very little circumferences. They're many points. Once we thought it was the atom, we broke the atom into different pieces, but different points. Is point-like, no internal structure. They came up with something called superstring theory, and now listen to this, that those little points are made of something even much smaller, but they are little strings. They are like violin strings. And those vibrations of those strings create reality. So they said, you're right, you have these problems because quantum took us to a very subatomic level, but it took to the little points. If you go to the little points, there is something more basic with a little strings that are called the superstrings, and the vibrations of the strings create reality. And it all comes from those vibrations. So depending on the vibrations, you see how it works, it creates reality. And this resolves, so the vibrations, they orchestrate the evolution of the cosmos. In 1984, what we spoke before, is the first piece of convincing evidence that the superstring theory provides the answer for everything. And this is the superstring. It's called the theory of everything. The superstring theory. And what is it? The idea is the following. The gravitational properties. We saw there are four forces in the world. The gravitational, and the electromagnetic, the weak, and the strong. The gravitational properties are determined by the energy of the vibrational pattern of the internal strings. And the electric, the weak, and the strong are determined by the way it vibrates. Not by the strength of the vibration, by the way it vibrates. If anybody wants to see the mathematics properties of those strings are fascinating. And today, all of physics are focusing on those strings, going to the world of the subatomic level, to the strings, which is the harmony and the music of the universe. So those are the four, all done by tiny, tiny strings. So I met the one who proposes, anybody who wants to read a great book, is Brian Greene's The Elegant Universe, The Theory of Superstrings. Anybody who loves it, he is a great physicist, but not only that, he goes ahead and he explains the mathematics in very, very plain English also. So when I met him, I went to one of his lectures. I told him, you know something? It's amazing because the Kabbalists always said that. The Kabbalists said that the Sphirot, God's emanations that created reality, they are always compared to strings. And let me show you the Talmud. The Talmud says in Arachim, look at this. The harp of the sanctuary says that it had 7 chords. The harp of the Messianic age will have 8 chords. And the harp of the world to come has 10 chords. As it said, with an instrument of 10 strings, God created the world. The Kabbalists say that this is the creation of the universe. The world that we live today has 7 strings that emanate that resonance of the world. the world of the Messianic age will be a world in a higher stage. It will have not 7 of those strings, it will have 8. And the world to come, which is the perfect world that we believe, will have 10 strings. The Ari, the Lurianic Kabbalah, the Rizal is Rabbi Yitzchak Luria, which is the father of Lurianic Kabbalah, and he comes to explain the Zohar. He's the interpretation of the Zohar, which was a revelation, again in the 7th, 16th century. And he says the following idea. He says, when God constricted himself, he left a little line, a little string, and that's the string of creation. I remember telling Brian Greene told me, yes, superstring theory, everybody told me that's a Kabbalistic idea. I've heard about it. If you ask Brian Greene, he says, the Kabbalists always said that the world of creation is a string that emanates vibrations. And that's how the physical reality was created. So, and this is a topic for tonight. I just want to tell you something amazing. That we have a legacy and a spiritual culture that was given to us that has all the secrets of creation of the universe and are there to be studied. It's amazing that we went from a scientific revolution of Copernicus to superstrings today. And the beauty of Jewish thought is something that we have dealt, and the Kabbalists have dealt with this reality for many, many thousands of years. And that's how we believe reality is all about. And it's amazing that as science started Copernicus, it was seen as the greatest challenge to religion. If you remember Copernicus, we started our class a long time ago. If you remember, our class was the challenge of Copernicus. Copernicus was put into the index of the church because it's a great challenge to religion. So people thought that science would be a challenge to religion. When you come to the world of superstring, challenge, not only science is not a challenge to religion, perhaps, like Niels Bohr said, the only way to really understand science is understanding religious thought. So as the greatest potential arch-enemy of religion became the ultimate companion. This concept of complementarity, the idea that you have two opposites, apparent opposites living together, particle and waves, can be said utmost of religion and science. And I think that hopefully will get you a good thought. This is like I told you that we went through hundreds of years and trillions of dollars and millions of man-hours put together into a very short 3 hours. But hopefully this survey gives you an idea of how the evolution of science has gone and how it went a full circle, 180 degrees, to its dialogue with religion. Thank you very much. If anybody has any questions, you're invited.